All right, and welcome back, everyone. It has been a very full 2 days. Each year, we try to bring a number of interesting presentations, panels, present research, give you an opportunity to get some insight into what's happening in the world. And we like to close it out in grand style with a noted practitioner, someone who can comment on the state of the world and give us some interesting insights to take away before and during the time up to the next annual symposium. This year, we're extremely fortunate to have such a visionary as our speaker in our closing keynote. Amit Yoran has had a long career working in government, in industry, and he has founded the U.S. CERT, which he led for a while. He founded his own company that was then later acquired. He was president of RSA and now is the chairman and CEO of Tenable Corporation, a major security provider. Through all of that, he's gained a tremendous amount of insight and contacts into the world of cybersecurity. You heard some of those earlier during the fireside chat. And we're now going to enjoy another hour of presentation, or 15 minutes of presentation in our closing keynote. So thank you for being here and take it away.
Steph, thanks for the invite. It's terrific to be here with you and the entire team. It's been for the sessions that I've attended, it's been awesome couple of days. So the title that I chose was something like everything is code, which hopefully I won't spend too much time talking about coding. I was an absolutely terrible developer. Probably the only thing I did worse than coding was computer engineering, which is what pushed me into computer science. They decidedly did not want me to be a computer engineer. So Spaff asked me to share some thoughts. And so what you'll hear today is a new talk. You're not going to hear one single mention of product. There's no stump speech ideas. It also means that what you're going to hear today are probably somewhat, or may seem somewhat disorganized thoughts. They aren't ideas which I've bounced back and forth with many people. So there's been very limited feedback. There's no polish. There are no pretty slides, but hopefully some real thought-provoking comments, and maybe we can have a little bit of fun with it toward the end in Q&A. Spaff introduced me as a visionary, which is always dangerous. Usually means you've got one of these gray beards. I'll tell you how visionary I am. When in the early 90s, I was running a network within the Department of Defense. Somebody came up and showed me what was to become the World Wide Web. And I was super excited. I was like, wow. And there's 500 sites on this. And you and the other 500 people with powerful enough desktops and fast enough access to appreciate will enjoy the web. The rest of us will stick with our Gopher and FTP and Telnet and email. So visionary, perhaps not. What I will try and do over the next 15 minutes or so is share some thinking on what I believe to be observations on the past, the era of computer security that we've been living in. And I won't say it's 2020, but I'm reasonably confident that I can accurately describe, or I've got some coherent thoughts around what computer security has looked like in the past, and then spend a little bit of time talking about the present. And when I describe the present, I won't claim a 2020 accuracy. I'll say I'm either completely wrong or maybe partially right in some areas, but unlikely in between. And then the future, which who knows? This is really difficult to do in our field. It's hard enough to see where we're at and where we're going over the next couple of years. If you start thinking 4 or 5 years out, beyond that is completely opaque. But if you start thinking about 4 or 5 years out, it's really hard to do, because you're not only predicting the changes in compute, it's becoming decidedly harder to predict how that compute is going to be used. The pace with which organizations are adopting change, are transforming themselves, is accelerating at an unprecedented rate. So, when you start factoring in, the pace of acceleration, it's really difficult to see how things will play out over any extended period of time. So a little bit about, the past and how we got here. Obviously, computers, held tremendous and hold tremendous promise. They make us faster, better, stronger, smarter, safer. The world of computing to date is also a very jumbled story. It's a very ugly story. It's a complete mess. It's one that is overridden by old servers and architectures and all sorts of complication and complicated legacy infrastructure that we've assembled over the course of decades between hardware and software, operating systems, applications, very little of which enterprises can really throw out. There are rare occasions when we can retire pieces of technology, and we should all celebrate that because it so rarely happens. But we tend to just collect baggage along the way. And as you do that, as you look at the differences in compute, and as people have had a chance to bang up on these forms of compute, what we've learned is that computers are decidedly not deterministic in nature. So all of the cool computer science stuff that we learn about Turing machines and finite state automata and all this sort of stuff is radically different than how computers operate in the wild. And Speff is probably going to cut me off and we'll go to commercial break. But the truth is that there are just an inordinate number of bugs and problems and challenges in the hardware and the software and the firmware and the applications, and our inability to retire things, whether they're legacy PCs, mainframes, local networks, routers, switches, desktops, BYOD. It makes these environments completely non-deterministic. And even things that you would imagine, that you would hope are deterministic, like standards, protocols, aren't, because not only the bugs, but vendors and manufacturers have developed them and built them using different interpretations or customizations on and of the standards which have existed. And so what we end up, and what all of these things end up in, is a high degree, have ended up in, is a high degree of non-determinism. You can't tell with any degree of certainty what state your compute platform is operating in. Just can't be done. And based on some unexpected number of unexpected inputs, some of which you perhaps have mapped out, it is nearly impossible to tell, because you don't know what those inputs are, what the next state of your system will be in. So those seams, that non-determinism, I believe, have become largely the gaps with which our adversaries have been able to take advantage of compute platforms in ways that we never would have anticipated, and make them fall victim. The challenges as we try and secure the sprawl of legacy computing, none of which ever seems to go away, is that this mess is constantly growing and constantly morphing. When you read the marketing literature and the vendor jargon, it's it's predict that, this, and futuristic that. I mean, the fact is, we don't know not only what state we're in, but how secure we are today, let alone be able to predict the future and the actions and the compromises and the vulnerabilities and the problems which will be discovered in the future. Every year, I mean, even just this past year, 20,000 plus new vulnerabilities were reported by vendors, researchers, security professionals, 20,000. And those are just the reported ones. So as we start thinking through, what is the state of our security? How secure are we today? It is incredibly difficult to assess. And your assessment could be wildly different than the reality that exists, because there are problems which people are taking advantage of or could be taking advantage of, which we simply don't know about. We haven't discovered them. We haven't understood them. Further complicating it is the fact that this world of compute is not just a technology problem, but we've built an ecosystem around the technology that is ill-equipped to deal with its dynamic nature, the volume and inefficiency. So, the current processes in an enterprise look something like this. InfoSec, red team, security assessment, whatever it is, trying to determine risk, finds a bunch of problems in some form or fashion. They hand it over to IT, which is a different group of people in a convoluted process. IT deliberates between operations, business units, costs, does some version of regression testing, assessing risk, avoiding change control windows and freeze windows, configuration management infrastructure and processes, and then consider some deployment timeline. And so the reality is that IT more often than not looks at this list of 2,487,862 problems and says, okay, security, thank you very much. We're off to the next business requirement. We're going to deploy the new capability, which our customers are actually asking us for, and will make the corporation more efficient or drive more revenue for us, rather than dealing with the things that you've discovered. So security has become literally the tax that nobody wants to pay, the tax nobody's willing to pay, or as often as not, doesn't even know how to pay. The problems are so great, and we're so entrenched in processes that don't adapt and move at the speed of technology and the speed of security, that we're in a it's not a never-ending loop. It's a loop. It's a vicious cycle which has us falling further behind. And that's basically how the security talk track has looked, with some variations over the last 25 to 30 years. So we're at what I think is a pretty foundational shift in how the world thinks about its computer. So I'll talk a little bit about what I think is the present, and I'll talk about it in two different ways, one of which is probably closer to accurate. We just don't know which yet. I don't know which it is. And so as depressing as that sounds, what we're finding now is that software, and we should say software, is eating the world. Well, okay, that's already happened. Every company is a technology company. That's now obvious. That's already happened. We're now operating in an environment where cloud is eating the world. The world of compute is changing dramatically. And of course, it's still, because of the way organizations operate, we still have all the legacy stuff to deal with. But now there's this new cloud thing, which is either really good or really bad. And I don't think we know which just yet. So I'll start off with the bad case, since it probably aligns more with how we've been thinking about, or how I've been thinking about the past world of compute, right? And what I can tell you about today's operating environments is that we really don't know what the hell is what, for lack of a better term. There's an abstraction which has occurred, and for amazing reasons of efficiency and productivity and innovation, there's this abstraction that has occurred between our compute platforms and our ability to understand and digest it. So what do I mean by that? We used to have this simple world where the problems that we created, but we knew were there. We had hardware, we had firmware, we had operating systems, we had software and applications, we had networks, we had routing, and those are all concepts that were fairly straightforward to understand. And we had decades of experience, many failures, but decades of experience building best practices around how to secure those things and that compute paradigm. Now, we don't really understand, or we've been abstracted from the reality of what's what. we don't know what our hardware infrastructure looks like. I mean, maybe we do for our iPad or our iPhone or our PC, but we don't know really where our servers are or what they look like and who has access to it. We don't know what is a local resource and what is a remote resource. We don't understand where data is and whose data is it and where it resides and where it traverses on its way to us and to our processing centers and applications. And in many cases, we can't distinguish between what is data and what is executable, which is a separate problem in and of itself. But we also have a high degree of automation where the data itself is changing how the system behaves. And these are all the things that we're going to discover in the 5G world. But even in a simple example, the data within the application changes how the application behaves and how the user interacts with the application. Something like Waze or a navigation app is a great example of this. Users report things, the data goes in, the system does its calculations. The data that is part of that system changes how the system interacts and the answers that it gives to its users. So it opens up a whole series of complexity which we do not really understand. And the way the applications work is also abstracted from us. As we write applications and function calls, we don't know, are these function calls local? Are they on our cloud? Are they on another cloud? Who's written them? What are the responses? What are the interactions with that function? And so the world of today, and this is not kind of where it's going, this is the world that enterprise applications are developed in. The world is just incredibly messy. And so that's the depressing case around things are going to get a whole lot worse as we embrace cloud. The attack surface is much more complex, much more difficult to defend. Our defense paradigms don't really make sense or aren't applicable, or we have a hard time applying them. And I'm not talking about firewalls. I'm talking about really the way we think about security isn't really applicable in much of today's most critical environments. I'll talk a little bit about where perhaps things are improving in today's environment, and I'm not sure which is which. But as we embrace cloud, we're changing how our infrastructures operate, and some of it can be more complex, but some of it can be much cleaner, much more efficient. The world is embracing infrastructure as code, as a new way of thinking about and managing IT. So it used to be, we develop our application, we call up IT, they provision us a system, the application goes on the system, and we're off to the races. And then we move to the first world of cloud, where you write your application, you call up IT, they provision you a virtual machine, you run, and you're off to the races. And that is, it's been an evolution of a paradigm that we're reasonably comfortable with. Today, efficiency is driving infrastructure as a code in ways that many security professionals don't really understand or appreciate. The code is an expression not only of the application and the executable, but through scripts, it is also the provisioning of infrastructure and the managing of infrastructure on which the code will be deployed at runtime. So again, it helps organizations develop incredible efficiency, incredible scale. You go from code to publication to runtime instantaneously, and you do it efficiently, and it doesn't require human interaction. Things like HashiCorp's Terraform and the whole category of alternatives. Amazing things which are occurring here. Build your application, deploy your application, and while this may seem problematic from a security perspective, it also enables things to happen from a security perspective that we didn't have in the traditional environment. We now have code repositories, the Git repositories. We have the ability to do not only assess the integrity of the code, but to assess the infrastructure as code, right? The beauty of this is that it is a digital representation of what the infrastructure looks like. And the infrastructure which is deployed is an exact instantiation of that code. It's digital representation. And so now, for arguably the first time, we have reintroduced a form of determinism back into our compute environments. I write the script, I know exactly what the environment is going to look like. I don't like it, I modify the script. I know exactly what the environment is going to look like. Now we have to account for things like drift and what happens in the operating wild. But there's an opportunity to drive security, compliance, resiliency, management into cloud-based infrastructures in ways that we lost control of in traditional environments, where there's different owners of the systems, there's different operating requirements, freeze windows, configuration management systems, different groups which own different parts of the process. All of that happens at code speed and through digital representation in code in the cloud. And so this get-centric mindset of not only provisioning, deprovisioning, but the workflows and the lifespan of our compute environment becomes a game changer in cloud-based environments. So this is the world we live in. It has new challenges for sure, and there's certainly a good argument to be made for the pessimist security practitioner who sees a whole bunch of abstractions and introduction of attack surface that they didn't see previously. But there's also new opportunity and digital representation and determinism that we didn't have in the old world and with the legacy baggage. Now, the one thing that we know is the corporations, the enterprises, the organizations, the government agencies that we work for will not, they're still using their mainframes and all the rest of the stuff that they've got. So we know that they're not going to let us get away with, okay, let's just migrate everything, not lift and shift to cloud, but rewrite everything for this very clean cloud world. We're stuck with the legacy baggage. And so one possible future, or the future that we can envision for improving security going forward, is applying this concept of everything as code in a near limitless way. It starts off determining how our cloud-based infrastructure is deployed, governing the rules of operation and management and performance of that infrastructure in the cloud. But over time, it's going to evolve. It's going to expand beyond cloud, because Git-centric operating models are compelling, and they can offer, I won't call it unimaginable, but tremendous gains in determinism and also efficiency. They can fix not only the legacy processes in the cloud, but over time, our legacy activities will move to this Git-centric mindset. So this isn't, in part, it's a wild-eye prediction of where things are going, but it's really not that hard to envision if you look at some of the things that are happening today, right? Let's look at a low-hanging fruit example. New hires come into an enterprise. HR has to rely on IT to onboard new hires. Incredibly, time-intensive, labor-intensive, requires armies of people, especially in high-growth industries where you're constantly hiring and there's high churn of employees. And so traditionally, HR has to partner with IT. They have to partner with facilities and finance and a whole slew of people to get new people onboarded and provisioned. So companies are starting to use HR workflows. Some of them Git-centric, some of them, traditional but automated. So they're starting to do workflows to programmatically provision systems, identities, authentication mechanisms, access, privilege, all of these things happening behind the scenes. The HR person inputs the data, kicks off the process, and the rest of the workflow escalates and executes in an automated fashion. So again, this is a digital representation. Somebody's written the code to automate a whole bunch of manual steps. So this really, in this example, it has nothing to do with cloud and everything to do with efficiency at scale. Yes, to access cloud, but also to provision and access on-prem systems and systems as well. So as we move into this new world where everything is written as code, everything is defined digitally with certainty, it applies to this shift left mindset, but it also starts defining the current state in the cloud, but increasingly the state of our legacy environments too. People will start moving directory services, user services, access and provisioning from the traditional Active Directory types of environments that they've got to a Git type of repo that can be defined, that they can interact with efficiently, and that can drive an automation and digitization of the mess that they've had to deal with. So these Git repositories, these cloud repositories, end up becoming the focal control point of how the enterprise operates, but also how it executes from an IT and a technology standpoint, with much greater focus, obviously, on protecting the repo, but also in the repo's ability to protect the enterprise. So code has become the universal language for IT, but increasingly for business processes. And now, of course, there's lots of all the layers of abstraction that can become problems and trip us up and that sort of thing. But this is the I think the next big shift that will be happening in technology as we really understand what the cloud brought to us. It's not just infinite scale and performance and stand up and tear down really quickly. It's really this incredible degree of automation and digital representation of exactly what everything's gonna look like. So, I don't want to quote Linus Torvald, but I'll say, when he says talk is cheap, show me the code, he might have more insight for decades ahead of where we find ourselves today, but certainly where we're going. So with that, I'd love to open up to the Q&A and talk with folks about some of these crazy ideas and where I've got it all wrong.
Well, I certainly wouldn't say you got it all wrong because we don't know yet, but it's some fascinating ideas there. So anyone who's listening, please use the Q&A here to post your questions. I'll ask as we go along, as we're waiting for something here. It seems to me that this is providing potentially more complexity for configuring some kinds of user services or user identities. And complexity has proven to be a problem in the past. Comments onto that?
Complexity has been the enemy of security for sure. And this does introduce complexity. The ray of hope that I have on this particular complexity is that it's digitally defined and represented in code, which means this complexity can be analyzed and understood in much more definitive ways than the complexity of some of the legacy environments that we've operated in. If it can be digitally defined, then we can apply different types of logic around protecting it and what it should look like.
Are you suggesting that perhaps applying AI to this is a way to go? Or, I mean, is that a natural consequence of this?
I think listen, for sure, AI is a natural, path to explore and can hold great promise. But even simply rules-based, even just a simple rules-based approach, we can weed out entire categories of problems that we've seen before. And because everything is defined, we know that our search for these problems can be complete in nature versus turning over rocks and finding all sorts of gems waiting for us.
Okay. I'm not seeing a lot of questions here from the audience. Perhaps this is too radical a view of the future for some of them to approach. Ah, we have one. Do you want to read it yourself, or would you like me to read it for you?
Do you think that AI will be automating code? It will also be automating more code, will be creating unimaginable problems in the future. This is a tough one. I don't want to go too far down the rat hole of singularity and those sorts of things. But the pace of innovation that we've been on has really taken a great hockey stick with computers and over the last 50 plus years. When the pace of innovation, when we have AIs that will be developing code, and I don't think we're that far away. I mean, some of it happens today, but right now we see AIs producing art, producing music, writing literature, to the point where some of it is very difficult to identify whether it's produced by a person or by an AI. When we get to the point where AI is innovating for us, then that acceleration, just everything that is humanly imaginable and even beyond that starts happening much faster. So I don't really. There's some terrific, thought work out there about, where this all goes. But I think that one of the biggest challenges is around sort of the application and the development of an ethics framework around these AIs before we get to that point, because different societies have different norms and ethics for behavior, and of course our own sense of morality on various topics changes over time. So I think defining a framework for this becomes incredibly important.
So looking towards Clark's laws of robotics as perhaps inspiration. How do you see the securing of the legacy end-to-end supply chain fitting into this?
There has been some work conducted on how you develop secure systems where you have, or trustworthy systems where you have untrusted or potentially compromised componentry. And so I think that type of analysis and work really needs to be dusted off and looked at much more closely. And it's a market and a world that we find ourselves in, and one that I think we're ill-equipped to deal with. SolarWinds was perhaps the prime example of that, where we've got a piece of software, and of course it's signed, so it's trusted, but it was in fact compromised and used to do nefarious things. And so I think we're really in an area where we're further and further abstracted from what these technologies are really doing, and fewer and fewer people are able to pull together the pieces parts to really understand what's happening. So the one thing I am confident in is that the traditional government approach of, hey, this is going to be done on US soil and it's going to be done by US nationals is both not scalable and or US companies is both not scalable and somewhat nonsensical, because even US corporations hire foreign nationals and have some portion of their software developed overseas. And even if they don't, they're relying on libraries and cloud-based infrastructures and open source components, which are produced overseas. And I'd say a vast majority of software today, 85% is software that exists, and the innovation is really happening in pulling different libraries together in different ways. So, our traditional approaches to understanding supply chain security and software security aren't I would say aren't applicable, but they're hardly applicable in today's world.
It's not directly related to your vision, but the recent executive order to have software a bill of materials, do you think that's even going to be possible for some of these bits of software?
I don't want to ask you what software is. That's how I feel like responding. What is hardware?
Fair.
What is hardware and what is software? Where is my operating system? And I'm doing an API or a function call. Is that my operating system? Is it a cloud function call? Is part of it happening here, part of it happening there? Whose cloud is it operating on? And it's just everything is software, but it's becoming increasingly difficult to draw the lines of distinction that we used to have.
I think that's actually a very fair answer. I have significant doubts about that order being successfully implemented across the board.
Yeah, but it'll get people thinking and doing something, and something is better than nothing. And hopefully it spurs great minds to think about the problem differently and come up with some exciting new ideas.
Sometimes prompting great minds does not necessarily result in good results, but I'll agree with you. We've certainly seen a number of very exotic ideas that seemed exciting, but just didn't go anywhere. So I'm not seeing much else in Q&A here. So we'll maybe go another minute or two. I think in part what you describe as really as kind of an evolution in the way that we configure and build software, because it envisions a kind of malleability of the underlying environment in which we can run, isn't easy for some people to grasp. You have the advantage of that bit of gray where you've seen enough evolution of what we've done in computing, where we've gone from single-threaded, single processor to the virtual machines in the cloud that are self-contained and variable. So it's easy to project that forward, perhaps. And I think I know, talking to some of the students in our program, they don't have that kind of perspective to be able to see that evolution in where we've gone. They know how to use things we have now, but it doesn't necessarily convey to them the potential to move beyond it. It will be interesting to see. And I'm also, I don't know if you've read any of the works by people like Charles Perrow, right? The coming disaster, emergent behavior, the idea that as things get exceedingly complex, we will develop catastrophic kinds of flaws that we hadn't anticipated. That's something we can't predict easily, right? Because it's emergent behavior, but would certainly cause a more complex system where we don't have the components right at hand and even understand the components that are going into something, because they're selected out of a workflow and they're out of a repository in different versions. Recovery from something might be more difficult than that. Or am I missing an element of what you're talking about?
No, I think that's, very accurate in these, low probability. Over time, they become higher probability, but, low probability, high consequence events just become more difficult for us to conceive of and therefore take corrective action prior to, them occurring. As we get further and further abstracted from how these systems actually operate. And of course, in many systems today, we have, fallback procedures and some manual overrides and things like that. But, over time, the big infrastructure things will look radically different, right? Everyone, if Elon Musk and the world of renewables, have their way, there's less reliance in these mega production facilities, and there's more self-contained. Everybody's their own power station and their own storage and that sort of thing. But then, of course, each one of these things is also computer production, transmission, distribution, storage. Those are all 100%, general purpose computing controlled and interacting with all of the other ones. And so there's really, all sorts of new challenges that are introduced that we're just going to have a hard time getting our minds around.
Yeah, there's an issue there of resilience, in that if you have replication, you are perhaps more resilient against single failure, but not necessarily against common failure, particularly if the people running those don't know. I think that's one of the things that I've talked about, and you and I have a background in computing, where at one point early on in our careers, although that's not to imply you're my age, but nonetheless, we were able to really understand at some level the operation of a computer, basically from the power supply all the way to the user interface. And the complexity that we've added, the number of levels of abstraction and virtualization and distribution, I don't think there's a person alive who can actually understand more than about 60% of that stack at any one point. And that adds another complication to what we have. As we get more specialized and it gets further spread out, we become more specialized in solving parts of the problem and not recognizing the bigger picture, which again is something that you brought us here in this great talk, is thinking a little bit beyond as to what the bigger picture may actually turn out to be. Well, we're not getting incoming questions, so let me give you a final one. We have right now during this talk here live, and also in the recording that we'll have, a lot of students, not just at Purdue, but around the world, who will have listened to this talk and this discussion. What kinds of advice could you give to them for what to study, what to think about, what their futures are going to be like? We've got an open mic and an opportunity to influence a generation here, so.
Well, I'll start off, with my opening remark that I completely missed the vision of the web when it was first presented to me. So don't necessarily listen to me. But what I would tell folks is, when I started getting into security, was sort of like the early 90s, and it felt very crowded. It felt like all of the big problems are already being solved. We've got firewalls and we've got ACLs, and we've got passwords, and we've got antivirus stuff, and we've got some early intrusion detection things are being discovered. And it seemed like, okay, well, we pretty much got our arms around security, and then lo and behold, 20 and 30 years later, the stuff is every bit or messier than it's ever been. And while there are some very well-defined best practices of hey, do this, don't do that, the world of security is still, full of virgin territory, new concepts, new ideas, because how people compute and how people use technology is changing so dramatically. So, what I would encourage, students to do is, if you're passionate about the field, pull on the threads that interest you, right? There's so many different aspects to computer security, information security, cybersecurity, whatever we call it these days. Pull on the threads that interest you, and that passion will lead you to places that will lead to success.
That's great advice and a wonderful way to conclude not only your talk today, but the overall symposium on a note of real hope, I think. And sometimes those of us in security are accused of being gloomy contrarians, predicting the death of everything, but that's a very hopeful statement. And thank you so much for your participation. We appreciate it a great deal. Thank you to everyone who's attended for these 2 days. We look forward to having you at the next symposium coming up, not a year from now, but at the end of March. This symposium was scheduled for the spring of this year, but because of COVID, we ended up postponing to the fall. The next one on time, on schedule, is going to be at the end of March. We'll have details on our website, and that March 29th and 30th. In the meantime, these recordings will be up shortly, as well as a lot of other ancillary material that we'll have on our website. Thank you to all our friends. Thank you to all the attendees. We look forward to interacting with you in the weeks and months to come. Have a good evening.